Hey there, everyone. Thought I'd give a update on where I've been getting on with the debugging symbols project that I've been working on. So just to let you know, I've done a bit of stuff off screen, just because I found a rabbit hole and I wasn't sure how deep it was and didn't really want to do it on screen. But just to show you where we are up to, if we go debug now, you'll see that it's got kind of names for a bunch of stuff, and if we do like rec, show, I don't know, let's do printf, and if we continue there, if we go printf here and say hi, it should pause in the right place, kind of. It's jumped 7 above, which I think is to do with alignment and stuff. But that can be another thing. And then if we look back, we have a backtrace, and it somewhat looks not quite right. Like it's got music stuff in there. So there probably still a bit of work to do, but it's got to a point where it's a lot easier to kind of step through things. And you can say, for example, you could break on printf and I don't know, maybe when we are doing percent %p, which I don't know how often we do that, but if we run that and go here and I don't know, echo 1 doesn't do it there, print f percent %p, we can't do that from the shell, but if we test print f, yeah, so that's now broken at the right point in where we're looking at, and that kind of aligns with CD coding, osdev. So that aligns quite well with DIO print f dot actually no, just percent %b, and so that aligns with their move prefix. So that's the offset for prefix. I wonder if we can actually get that sort of stuff in at some point. And then we jump to %x. So that's pretty cool that we can kind of jump right to where we need to do, and we don't have to kind of worry about the manually calling int3. So I thought I'd talk through a bit about where I got up to. Now I think, so I'm just about to make a commit of all the stuff I've done, included a bit of refactoring. And here's the assembly file that I've been using kind of as a test to see what we should include and what we shouldn't. And it kind of uses a mixture of a bunch of stuff that I already use in the code base for the operating system. So it's got structures, and we've got external functions, we've got things that we go public, we've got private stuff, we've got stuff that we don't use, which can be useful because like you could have multiple labels for one endpoint and you might never actually jump to it or call to it, but it's useful in the debug output to see, it's at that point, I can find that string. And we also use a macro to wrap around our public function, so we test whether that still works there. And the output of that, if we we can actually run this one. So that gives an output, and what we end up doing is basically including, we have a wrapper and we include the file that we are basically compiling, we get rid of the macro that we had for public, and then we basically declare everything as public. The reason why we do that is if we look at that and read of that one, so we can see that his so the first file only really has the stuff that we had done external or public on, so it's got those three there, whereas this test debug has all that stuff that we had, plus it's also got a bunch of extra symbols, so that way when we come to debug we can lean on those symbols. Now I think in the last video, was a while ago, in fact if we look at my status, yeah, so we had this one, if we run this file on that test.debug, alright, so this one doesn't actually work because we added some more stuff to it, but my idea was that we could basically have in our test file we, instead of doing all this stuff, I was thinking we could do section .str tab and kind of manually write in all the strings and then do the same for the symbol tab. The way fasm works, turns out you can't do that. It will create a, well, we can actually see what happens, but sim tab, so yeah, if we just do something like that and then fasm that and then read out of this one, except do wide and summary, you'll see here it's got a sim tab here with no bits and then sim tab with str tab. So that no bits is the one that we can control, but it's not in the format that we want. We want it to have this type here. So that was kind of my first rabbit hole. It didn't really work. I found, where was it? Yeah, this article here. What I will do is just create a description for this, because I'm got a we actually went 11, we'll go 10 and then up that to 11, and then in here we'll add some more stuff. Yes, that's all that stuff. Maybe down here, fasm elf blog post, and we'll just pop that in there, and I'll add the later parts in because now we've done well, part 3 and part 4. So yeah. Anyway, that was a bit of a tangent. So the idea here was this you can include another file which has basically these constants defined, and we can kind of construct the correct tables to do the right thing. So this example kind of just calls printf, which is external to this. Now I think I have this one, which is that file there. So if we compile this, does something, and if we look at what it has, so it's assembled to a binary, which is a side effect of having to put that executable there, which allows us to use the segments over the sections, but it also means that it compiles to a binary. So we see here that it's an executable, but there's also no sections, so we can't kind of do that same trick and when you do it, it kind of runs. And I think, if we go break printf or something, it doesn't know where printf is, even though we run it. Like we have a call to printf. So that kind of wasn't a good rabbit hole, and I might do some cleaning up, to be honest. So we'll get rid of that. So we couldn't go down that track, but I did notice that when you public a thing in fasm, then it adds it to the symbol table. So my idea there was to basically take the file, so this one here, for example, take that and then add the wrapper, which we have done there, and add publics for everything that we want. Now the problem is if we add, say, that variable there, test no publics, and if we try and do that again, it works. It works, but when it comes to linking, it has the unfortunate problem that it has test no publics there and also there, so it has multiple definitions of it, and when you come to link it, it basically spits out a warning, which this might do the trick. So this is the error that we get, multiple definitions of that function there. So we have a bit of a conundrum that we want to put everything in here as public, but then not do the stuff that we've already done as public or already had external, or might just be some weird features like a structure definition that uses the virtual mechanics in fasm. So what I've done is I have kind of changed the layout a bit. So I did some refactoring. So if we look in tools faz, for example, here we have cut down a bunch of stuff and we include basically all of the different types, and that's just like reading it and dumping it, and then each of those subtypes kind of have all the offsets and stuff, and I've got a lot more helpers to, right, that gets the process line, here's some flags. You'll see that the flags, I've kind of added a few more because you can have up to 16 flags, but they only had 11, I believe, which we can see in here. Flags, so flags takes up, where are we looking? Symbol, yes, this is flags, so flags takes up a word, so 16 bits, and the flags here we only have 11, so we can use an extra 5. So what I've done is basically add a couple of flags that we're looking for, which then we have to go through and work out where they are. So public, virtual, external, and macro. And if we look at the tools generate, this one, what we do is we go through and process them. We'll come back to that. And then here, when we're looking at a symbol and working out whether we write it, we don't want to do it if it's a variable, so an assembly time variable, because it's not going to be publicable. And then we also don't do it if it's public, virtual, extern, or a macro. And we set those by going through the data structures. So the first thing we do is I'll just do that. So the first thing we do is we go through the symbol table. So we're looping over all the symbols in this loop, and then we get the processed line of the symbol, then we get the first token of that, and then we check whether it's extern. So that's basically a symbol that is being marked as extern, which is already getting put in the table, so we don't need to do it. So we set that flag on the flags. Next up, we see whether it's a macro, and if it is, we set the macro flag. Then we go through all the symbol references, because annoyingly the format doesn't actually have it all in the same place. So here we can get the symbol reference, then we get the actual symbol, and we also get the kind of assembly dump from here, and we bind that to sim and assembly. And then from the assembly dump, we get the assembly pre-process line and check whether that's public. Well, the first token is public, and if it is, we set public on the symbol. It's weird that this never showed up in the symbol thing, but yeah, I guess it's because it's getting referenced to throw to the public. And then we also check whether this is inside a virtual block, and if so, we set that. So this code is a lot simpler than what we have. And then to generate this, we basically get the file name, add a debug to the end, and then we loop over all the symbols and print them out to that file. What we could do is, if we run that again, where do we have it? Porth. Except run this new updated copy. Right. Yeah, so this one here. So here I've turned on dumping. So you see here it had that same information that we had before, the major minor. I've decreased what the header output shows because it's mainly just offsets, which we can kind of show in the various places. So that shows the input output file names, all our strings. We don't actually need to show the strings because they're kind of linked from other places. Now in the symbols, we can see that we've got our flags and we kind of print them out. That's something that I thought would be useful. And we also print out all the tokens. Some have multiple tokens, and if it's like a macro, also where it's used and then where it's defined. So this tool is kind of useful for parsing that debug file, which we might use in the future. We might not. But yeah, you'll see here, this has got my kind of custom flags in there, which are then looped back over. We can also dump out all the sections that we have and the symbol refs, which kind of show some different data. And you'll see here that this one has a public, but up above we could never find that it's public just from the symbols. It's just how that cookie crumbled. But yeah, so that's basically that. Might just comment that out again. Yeah, sure. So yeah, we've got this new file. Now I had to do a couple of changes. Not sure why, to be honest. In fact, yeah. Let's not do that and not do that. I think we did need to do this one because end was being used in a funny way, so I've just changed it to fin. And we'll check that we can still debug and it does the things and it goes reasonably quick. Yeah, cool, that looks good, and we can kind of see where it stops up stuff. So there's stuff to fix because we're seeing music is like in a right place, but I think this has come significantly more than where we were. We also need to do that and get rid of that. And then our actual copy that we can commit up. So I'll just step through this while I'm making the commit. So we can see here that we kind of intercept this fasm assembling. So instead of just assembling it, we now assemble it and we output this debug file to the build door. Then we run that command that generates a new one, then we assemble that, then we use that symbol as our final object that will compile in, and we compile the porth up here just so we don't do it every time. And this was the file that we just had a look at, and all these kind of custom definitions of all the little subsections, I guess. Section's a bad word because section's part of it. The lines, pre-processed lines, they call them, the docs. And string table, and symbol reference table, symbol table. There's some like commented out stuff there, but that's alright. And types then. That's kind of the file that dumps it out. So I'm kind of happy with that. So let's commit that up. Tools, add, to build chain. Now this will actually, what I might also do is remove that debug.porth that we had started, and maybe do a bit of a clean on some stuff. I can't do that. I was thinking of just doing a git clean, but the way the video works is it's currently getting recorded. You'll see went up a megabyte of me showing a megabyte doing that. Bit of a waste, but so we don't need that, we don't need that, we don't need that. These are just kind of things I was playing with, and that was, I suppose, I'll kind of show what, now they've deleted that, but porth com tools debug dot porth, and so here let's just make another one. Format elf section dot now we can just do like foo. So if we do that and test.dbg and do that and test.dbg. So this one was a similar file that I had just adapted from our existing one. Which does roughly the same thing, but if we look at it, it's 500 lines of stuff, and stuff was kind of just all in a funny order, so I thought I would just change it and not have it all there. Right, so that and that and there's also like some objects that don't get removed because yeah. There should also be. Oh no, I think I did that at another point. But yeah, we also run this command here in our Python GDB setup to basically load the symbol file that we added in. So yeah, let's just roll that up into that, and I think I'll push that up to probably should have tagged it as this feature here. Now there is kind of one issue that we have. Yeah, it's kind of like a work in progress, but I have a feeling that I will probably leave it at this because it's significantly better than nothing. But there will be some bugs in the backtrace code that we have, for example, which that use the this kind of wrapper thing. In fact, let's take that out. Yeah, it kind of had this wrapper thing that added the function to another section, which, yeah, it's annoying that that wouldn't work for us. So why I say it wouldn't work for us is if we do this and porth and purge. So if we don't include that purge, then we try and build that. Here we get stuck on, we compile one file, so we get the boot, but then we start doing the VGA and it doesn't like it. And if we, good thing that it failed, we can have a look at it. So it's should have theoretically all the same stuff just without that purge, which means that it will be using this function, this macro, and that does something that it doesn't like. It might build up the, yeah, it might just build it up too much. I think in the first case though, that just having the public things that we manually define as public in the backtrace is probably suitable, because those are kind of the library functions, I guess. So yeah, we'll leave it at that. But yeah, that's one of the side issues, and not having kind of the most accurate backtrace is also an issue. Yeah, I noticed yeah, if we do this and if we break it, I think it was, yeah, this one, I mean probably any, but if we break it this and go backtrace, we'll see we've got like a weird entry at 15, which shouldn't be, and we're for some reason executing code at that point. So like there's definitely stuff that I could fix up, but that's alright. Yeah, I think that's probably it for this video. I might just remove that. Includes remove to so we'll push that up. Oh yeah, that's the other thing. What do we have? This is half an hour. Yeah, what I'm thinking now is if we look at our sweet pipeline from pushing that last change, we'll see it failed because it doesn't know how to build, because we now use porth and it has no idea what porth is. Yeah, no such file or directory. So what I might do is get porth. So porth came from here. So here we do we have git at this point? Git clone that to where were we trying to run it? Source porth. I hate how you don't have like tab completion and an editor of a shell script. Right, so what do we need to do to get porth going? Yeah, so we want to fasm that. I might actually do a tools build porth.h. Yeah, and what do we need to do? We need to do that. Get all the common stuff. Yeah, so and then we can kind of do it this way, and get that first one. Yeah, I think that will do the trick. And then in this one, porth tools build porth.sh. Tools build porth. So if we do that, yeah, in fact, sure. So if we do that, it should theoretically get us to a point where we can do tools build. Yeah, cool. So that's working. We shouldn't have to bootstrap porth every time, so it should just do it as part of that. Push that, then this should theoretically pass this time. Once that finishes pushing, then this should pick up a thing. So this build should work. Right, so I think that's probably all I need to do today. Hopefully that this just works as intended. But yeah, I might just fix that up off screen. Thank you very much for watching the video. If you've enjoyed it, then let me know. Otherwise, now that I've finished this little side project, I'll be back to getting work done on the actual operating system. I've got a few ideas in mind, so stay tuned for next time. Have a good day.